All right, welcome to our lesson on the area of regular polygons. Before I get started, I have to apologize. I'm doing this from the wing of an airplane as we're flying across country, so the noise might get a little bit loud. I apologize for that if it bothers you. All right, a regular polygon is both equilateral and equiangular. All of the angles are congruent, all the sides are congruent. Equilateral triangles, squares are examples of equilateral or regular polygons. Any regular polygon can be inscribed in a circle, like this, or that, okay? Therefore, some of the properties of circles, like a center, each of these have centers. There is a radius. From the center to the vertex is what the radius is. So those would be the radii of that equilateral triangle. The radii, which is really half a diagonal for a square, and these are radii for that pentagon down there. We could also say that there's a central angle. There is a central angle. It's formed by the radii. So the central angles are marked as so, and you can calculate that pretty easily. 360 would go all the way around the circle. Well, there's three in that triangle. There's three central angle, so 360 divided by 3 is 120 degrees, 360 divided by 4 is 90, we should have known that about squares already. 360 divided by 5 is 72 degrees, are the measures of the central angles for a triangle, square, and a pentagon. Just 360 divided by the number of sides. There's one thing that a circle doesn't have that a regular polygon does have. It's called an apothem. A-P-O-T-H-E-M. That is the distance from the center to the side of the regular polygon. This is always perpendicular. So in the triangle, the square, that is what the apothem is. If that looks like it's the altitude of that triangle, it is. An apothem is an altitude of the triangle that's created by the radii and the side of the triangle. So, in fact, look at those triangles right there. Those two radii, the side of it, it creates an isosceles triangle where that apothem is the altitude. Another part of that, an altitude, of course, bisects that isosceles triangle. We've learned that. So we could look at one of those right triangles. If you think of one of the radius, the apothem, and then half of the side, those make right triangles, which are going to come in handy. Specifically, think about this for a second. If we have this, if there's a 120-degree angle here, that gets split in half, what type of triangle is this? Did I hear somebody say 30, 60, 90? Yep, you betcha. The equilateral triangle has the 30, 60, 90 triangle right there with the apothem and the radius. What about the square? Yep, 45, 45, 90. Those special right triangles are going to come in handy at some point in time. The pentagon one, there's nothing special about that one at all. That's just a right triangle. Okay, so I can do this for any of these. I'm not going to go through all of that, but I'm going to identify the radius of this hexagon. The central angle is 60 degrees. That would be the apothem. What type of triangle gets created right there? Yep, that's a 60-degree angle right there, so that's a 30, 60, 90 triangle there. That's an equilateral triangle there in the middle. This is an octagon, so there would be 8 of these triangles right here. That's a 45-degree angle, but if you split a 45-degree angle in half, it doesn't create a special right triangle. That's 22.5 degrees. But that's where the radius and the apothem is. Here's a nonagon with 9 sides. It has radii with a 40-degree central angle and an apothem. This one, how many sides is this? 1, 2, 3, 4, 10. That's called a decagon. Radius, the central angle of the decagon is 36 degrees. The apothem is there. And this is how many is this? That's 12. That's a dodecagon. Radii. 30-degree central angle, there's your apothem. The ones of note, of special note, are hexagon, square, equilateral, triangle. Why? Because they make those 30, 60, or those special right triangles, I should say. And so those are going to come in very, very, very handy. The other ones, well, we'll learn the trick for those in here just a second. What I'd like for you to keep the idea of is if I know the area of this triangle right here, well, how many would there be going all the way around the circle? There are 10. So if I know the area of this triangle, multiply it by 10, you'd have the area of that decagon. If you know the area of this triangle up here on the octagon, times 8, that's the area. All right, so those are all the important pieces and parts of these regular polygons. Let's talk about area. So the area of a regular polygon is equal to half the product of the apothem and perimeter. This is a, well, depends on what information you have. Of course, if you're talking about a square, use the square formula, but sometimes you don't have, well, it depends on what you have. But so the area equals 1/2 times A times P, where A is the apothem, P is the perimeter. I would note that this is, if you take the area of one of those triangles like we had on the other side of the page, times the number of sides, or the number of triangles, that would also get the area of it. All right, so here's some examples. Find the perimeter and area of a regular triangle with apothem 9. So there's our regular triangle. This would be where the apothem is, it's 9. To find the area then, we have the apothem, we need the perimeter. All right, what type of triangle is this then? Flip the page if you don't remember. That ends up being a 30, 60, 90 triangle with a 60-degree angle right here. The central angle was 120, got bisected. So the short leg of this 30, 60, 90 triangle is 9. What would be the long leg right here? 9 square root of 3 is the answer for that. So what is the whole one side of the triangle? Double that, 18 square root of 3. How many sides are there? Well, there's 3 of them. So 18 square root of 3 times 3 is 54 square root of 3. That would be the perimeter of that. Just to back that train up one time, to just do it again. There's the apothem. This is a 30, 60, 90 triangle. 9 is the short leg, so the long leg's 9 square root of 3. Double it to get the side, times 3 to get the perimeter. Okay? So now I got all my parts. The area is 1/2 times the apothem, 9 times the perimeter, 54 square root of 3. You can either give me this answer, 243 square root of 3 units squared, or 420.9 units squared is what I will take as well. Next example, find the apothem and radius of a regular quadrilateral with area 100. Well, so what do we know about the area of a square? That means that the area is the side squared. So what is one of the sides? 10. Good. So if the side is 10, then each part of this triangle here of the right triangle is 5. This is a 45, 45, 90 triangle. So what is the length of the apothem? It's 5. All right, so now what will be the radius then? The radius is going to be the hypotenuse of this 45, 45, 90 triangle. So the radius is 5 square root of 2. All right, so we worked our way backwards on that one. All right, question C. Find the area of a regular hexagon. Before we get going here, let's remember what central angle is created by a hexagon. Did I hear somebody say 60? Yes, a 60-degree angle goes right there. So if the side is equal to 12, then that ends up being a 60-degree angle down here. It's an equilateral triangle. If the side is 12, then part of that is 6. If the side is 12, 12 times 6, the perimeter is 72. We need to break it into half down here so we can figure out the apothem. The short leg of this 30, 60, 90 triangle is 6, so the apothem would be equal to 6 square root of 3. So we got all we need to find the area, 1/2 times the apothem times the perimeter. Whoopsies. There. Will get us 216 square root of 3 units squared. The decimal version of that would be 374.1. All right, this next series of questions here, 4 through 9, say find the area of each regular polygon given the apothem and the length. Well, I'm going to do number 9 for you. That's a dodecagon. It's got how many sides? 12. So the perimeter, if a side is 14 centimeters, the perimeter then is 168 centimeters. It gives you the apothem. 1/2 times the apothem times the perimeter. That right there is the area. That's not hard work there, ladies and gentlemen. Go ahead and figure out the area for 4, 5, 6, 7, and 8. better see some work to see these answers. All right, so these questions down here, we got a pentagon. It gives you the apothem and a length of the side right there. For number 11, that is an equilateral triangle, so the central angle is 60 degrees. On number 12, that's a square, so the central angle is 45 degrees. And number 13, that is an hexagon. I've been saying the central angle. Not the central angle is 120 up here, but this angle is 60 degrees of the triangle. Same thing here. That's not the central angle. The central angle is 90 degrees, but that angle is 45 degrees. And then this angle here is 30 degrees. Find the areas. I'm not going to show you the answers at this point in time. I want to see if you can get these right. Show me some work. You can do it. Okay, bye. Get some rest.